Okay, now we're going to start with section 5.1. This changes gears a little bit, and we're going to talk about polynomial functions in general. We've already talked about linear and quadratic, and those are types of polynomials. Now we're going to expand out what we've done in general to some more functions called polynomials. This section is one of those where it's a little bit difficult to get through, but once we get through it, it all makes sense. So this tends to be people's favorite section out of the entire semester, so just have a little bit of patience, stay with me, even if you're not seeing why we're doing each part, and then in the end it'll kind of all come together and you'll be able to make sense of all of it. Okay, so to start with, we need to start with a definition. Definition might look a little scary at first, but stick with me. So, let's move that down here. Okay, so our definition is that a polynomial function has this form, okay, and this might look a little bit weird at first, but trust me. So it's an x to the n plus an minus 1 x to the n minus 1 plus ... means continue on in that pattern, a2x2, a1x, and a naught. All right, so why all these funky letters and numbers? Well, the n's, and here are the 2's, and here are the 1's, and here are the 0, those are called indices. You've seen it before with x1, y1, x2, y2. Why do we do that? Because we know that x2 goes with y2. We know that x1 goes with y1. It's the same idea here. All of the a's are coefficients, and we know that an goes with x to the n. We know that a2 goes with x squared. So if somebody said, what is the coefficient a8, you would know that's the coefficient in front of x to the 8, so a8, x to the 8. So it's just an indexing so that we know which letter goes with which variable. It's better than like a, b, c, d, e, f, g, because then if I say, what's coefficient m, you got to figure out which letter that goes to, which exponent that goes to. So it's an index that just helps us know what's going on here a little bit better. It's kind of a little bit more sophisticated than using different letters. Okay, so all of these coefficients a are real coefficients, real numbers. So positive, negative, fractions, decimals, they can even be like square root of 2, they can even be pi, we just don't have any i's, no complex numbers in there. We also have that n, the exponent, is a non-negative integer. So remember, integers are like whole numbers, positive and negative, so we can have like 4, 5, 6, 7, 8. We can also have -1, -2, -3, and 0. So if it's non-negative, that means we have 0 and all of the positives. So if this n right here has to be 0 or positive, that means that all of these have to be positive. So we're looking for positive whole number exponents. Okay, so we're going to have real coefficients. They can be just about anything. And our exponents have to be positive whole numbers. All right, when we have that, we have a polynomial, and we say that n is the degree of the polynomial. So the highest exponent, whatever order it's in, the highest exponent is called the degree. All right, so let's look at some functions. Let's look at some relations and see if we can decide if they are polynomials. All right, so let's say I have the function x cubed minus 5x squared minus 1/2 x. Is this a polynomial? And if so, what is the degree? Okay, so let's see if it meets our criteria. Are the coefficients real numbers? We've got 1, -5, -1/2. Are those real coefficients? Yes, they definitely are. What about our exponents? Are they non-negative integers? Are they positive whole numbers? 3, 2, 1. Yes. So it meets our criteria here. Yes, this is a polynomial. And what is the degree? The degree is the highest number, the highest exponent. The degree is 3. Okay, so this is what we're looking for polynomials. Let's say that we have x to the 4th minus 1 over x. X to the 4th minus 1 over x. Okay, are the coefficients real? We've got 1 and we've got -1. So yes, the coefficients are real, but what about the exponents? We need the exponents to be positive whole numbers. Well, our exponent here is 4, that's fine, but what about this one? Well, we need to remember what a reciprocal really is. And just in case you haven't seen this before, let me write this off to the side. Okay, what a reciprocal is actually an exponent that is negative. So x to the -1, a negative exponent means flip it. Okay, so if you haven't seen that before, that's what that means. A negative exponent means reciprocal. So when you see this x in the denominator, if you have an x in the denominator, that's a negative exponent, and that is not allowed. We have to have non-negative exponents. So this is a no. And since it's not a polynomial, we don't have a degree. All right, let's try another one. Let's say we have x squared plus the square root of x. All right, do we have real coefficients? That's fine. What about our exponents? The 2 is fine, but what about this one? What about a square root? This is another one that you should have seen before, but just in case you didn't. If you have the square root of something, that's actually an exponent of 1/2. Okay, so square root is an exponent of 1/2, cube root is an exponent of 1/3, so on. Anytime that you see a root, that is a fraction in the exponent. Can we have fractions in the exponent? Nope, we got to have integers. So this one is a no. So if you see an x in the denominator or an x in the square root, the answer is no. You can have numbers in the denominator, you can have numbers in the square root, but you cannot have x's. All right, how about this one? Y is equal to 0.7x plus 3x to the 5th. Is this one a polynomial? Do we have real number coefficients? 0.7 and 3. Yes, those are real numbers. Do we have exponents that are non-negative integers? 1 and 5. Yes, we have a polynomial. Okay, this one matches the criteria. What is the degree? The degree is the highest exponent, which is 5. Okay, so it's not always the one out front, it's always the highest one. All right, last example. Let's say we have x plus 1 times x plus 2 times x plus 3. Is this a polynomial? Well, we could multiply this all out. Okay, we could multiply x plus 1 times x plus 2, FOIL that all out, then distribute the x plus 3. But we don't really need to do that, okay? All of these coefficients are real. If I multiply them together, will they still be real? I'll have things like 1 times 1, 1 times 2, 2 times 3, 3 times 1. Yes, those will still be real. When you multiply real coefficients, you get more real coefficients. Okay, so yes, we start off real, we're going to finish real. Now, what about the exponents? When I multiply this out, what am I going to get? I've got x times x times x. I'm going to end up with things like x cubed, x squared, x, and numbers. Are those all parts of a polynomial function? Yes, all of those exponents will be positive integers, x cubed, x squared, x, and numbers. So yes, this is a polynomial. If you have this one, x plus 1 is a polynomial, multiplying by another polynomial, multiplying by another polynomial, it will be a polynomial. So yes. Now, what is the degree? If we multiply this out, what would be the highest exponent I could get? It would be x times x times x. It would be x cubed. So you can either think of it as having 3 factors, or you can think of it as x times x times x. The highest thing that we could get out of this is x cubed, so the degree is 3. So we can actually answer this without having to multiply it all out, which is good.